Hello everyone. Today we're going to learn how to graph quadratics in vertex form. So if we have something of the form f of x equals x squared plus k. K is a number that is telling us to translate the graph either up or down. So we're just shifting the graph up or down. If k is positive, then f of x equals x squared is translated up k units. And if k is negative, the graph of f of x equals x squared is translated down k units. Remember that f of x equals x squared is considered the parent function. A parent function is the original function that has no transformations. So x squared is our original, and then we will be either adding or subtracting k from it. So if we look at example 1, it says graph f of x equals x squared plus 2. What is the translation? Well, this plus 2 on the end tells me that I'm going up 2 units from the parent function. So you can see that the parent function is graphed here in gray. And to graph my new function, all I'm going to do is move each of these 5 ordered pairs up 2 units. So I'm just going to move each one of these points up 2. Once I do that, I'm going to go ahead and connect these points to create a parabola. Remember that parabolas are U-shaped, not V-shaped, because a V will give us an absolute value function, and here we are graphing quadratic functions. So you can see that I've just shifted each of these points up 2 units. My new vertex is right here at the point 0, 2. Let's try that again with number 2. It says graph f of x equals x squared minus 3. So this negative 3 is my k value, telling me that I am going down 3 units. And so I'm just going to take each one of these points here, and I'm going to shift them down 3 units. And once I do that, I'm going to go ahead and connect these points in a parabola. This parabola does go on forever. That is why I am including my arrows at the ends of my graph. The vertex of this new function is the ordered pair 0, negative 3. Just like how we can shift the function up and down, we can also shift the function left and right. So here I have, graphing f of x equals x minus h squared. So if you have x minus a number, then that means that you're going to be moving right h units. And if you have x plus a number, then you are going to be moving left 8 units. So on number 3, I have f of x equals x minus 2 squared. Here I have x minus a number. So that's telling me I am going to the right 2 units. And so I'm just going to shift each one of these points right 2 units. 1, 2, 1, 2, 1, 2. And then I'm going to go ahead and connect these points to create the parabola. The vertex of the translated function is the point 2, 0. On number 4, it says graph f of x equals x plus 1 squared. So here I have plus 1 inside my parentheses. So if I have x plus a number, alphabet tells me that I'm going to the left. So this must mean that I'm going left 1 unit. And so I'm just going to move each one of these points left 1 unit. And then I can go ahead and connect these to make the parabola. My new vertex is at the point -1, 0. Let's put that all together in a couple of examples. So on number 5, we have graph f of x equals x minus 1 squared plus 2. Well, let's see. The x minus 1 tells me that I'm going to the right 1 unit. And then the plus 2 is telling me that I'm going up 2 units. So I'm going to take each ordered pair and go right 1, up 2. So I'm going right 1, up 2. Right 1, up 2. And I'm just going to keep doing that. And now I can go ahead and connect these points to create a parabola. The vertex of the translated graph is the point 1, 2. Go ahead and pause the video and see if you can try number 6. So on number 6, I have x plus 2 inside parentheses, which means that I'm going to go left 2. And then I have the minus 4 on the end, which means I'm also going to go down 4. So I'm going to move each point left 2 and down 1, 2, 3, 4. And I'm just going to do that for all of the points. And then I will connect those points to make a parabola. That new ordered pair for the translated vertex is -2, -4. There we go. We can also have an a value. The a value is the coefficient of x squared. And so if we look at example 7, it says graph f of x equals -x squared. So my a value here is -1. And if you're not sure what a -1 a value does, that's okay. We can use the table of values right here to help us figure that out. And so all I'm going to do is I'm going to plug in -2 for x squared. And so then I'll have -2 squared. To fill in this table, you can either use a calculator or you can use your brain using the order of operations, whichever is easier for you. When you plug in -2, you get -4. For -1, you get -1. 0 is 0. When you plug in 1, you get -1. And when you plug in 2, you get -4. So I'm going to go ahead and plot these points. And draw my parabola. So when this happens, when your parabola flips and goes to the other side of your x-axis, this is called a reflection across the x-axis. And that will always happen whenever your a value is negative. Here my vertex is still the point 0, 0. So our vertex did not change. On number 8, our a value is 2. So let's see how that changes the function. So again, I'm just going to use my brain and plug in these different values for x. You could also pause the video and use a calculator. Here I'm going to get 8, 2, 0, 2, and 8. And I'm just going to go ahead and plot those points. And so here is that new parabola. Whoops. That should be at 2. There we go. All right, so what happens is if you look at this graph has been pulled up. It's been made skinnier, right? This point has now moved up here. This point has now moved up here. And so it's like we're holding it and we're stretching it. And so this is a vertical stretch. And you could even say vertical stretch by a factor of 2 because we multiplied by 2. Here my vertex is still the ordered pair 0, 0. Excuse me. Let's see what happens on number 9. So here I have graph f of x equals 1/2 x squared. So again, I'm just going to plug in these x values in for x into my formula. And when I do that, I get 1, 0.5, 0, 0.5, and 1. That's not right. When I plug in here, I should get 2. Sorry about that. There we go. And then I'm going to connect these points to create a parabola. And so what we've done is we've kind of squished this parabola down. We've taken this gray one and we've squished it, right? We've made it smaller. And so this is considered a vertical shrink. And here you can see that my vertex is the ordered pair 0, 0. So let's kind of summarize all the different types of transformations that we've discussed so far. So your A value, this will tell you if you have a reflection, a stretch, or a shrink. X minus H will tell you if you are moving left or right. And K will tell you if you are moving up or down. So the graph of f of x equals x squared will stretch vertically if A is greater than 1. The graph of f of x equals x squared will shrink vertically if A is between 0 and 1. The graph of f of x equals x squared will reflect across the x-axis if A is negative. The graph of f of x equals x squared will translate up, so move up, if K is positive, and it will translate down if K is negative. The graph of f of x equals x squared will translate right if you have x minus h, and it will translate left if you have x plus h. The reason why this form right here, so this form that we're talking about right here, is called vertex form is because this equation gives you the vertex. Your vertex is always of the form HK. So you'll always be getting your vertex from your H and your K value. And so let me show you what that looks like. It's the most obvious on examples 5 and 6. So our vertex is HK. 1, 2. If we look at number 6, here our vertex is HK. -2, -4. Because we're inside with X and our formula has a negative in it, that's why we have to change the sign of H. So you are always going to change the sign of H. So -1 becomes +1. And you're going to keep the sign of K. 2 stays 2. Change the sign of H. 2 becomes -2. Keep the sign of K. -4 stays -4. So every time you're given an equation in this form, you automatically know the vertex. So the vertex form, oops, sorry about that, of a quadratic equation is y equals a times x minus h plus k. So let's put all of this information together on example 10. So on example 10, it says graph g of x equals 2 times x minus 3 plus 1. And so what I'm going to do first is I am going to find the vertex. So my vertex is going to be at HK. So I'm going to keep the sign of H, change the sign of H, keep the sign of K. So -3 becomes +3, and we keep +1. I always want to have my vertex in the middle of my table. So that is going to be my vertex. To figure out what numbers come next, well, after 3 comes 4, and after 4 comes 5. Before 3 is 2, and before 2 is 1. So I'm just going to go ahead and plug these values into my calculator to get these, or you can plug them in and use your brain and use the order of operations. And so when I do that, I get 9, 3, 1, 3, and 9. And so I'm going to go ahead and plot these points. And once I have those points, I can connect them to create a parabola. Remember, parabolas are U-shaped, not V-shaped. The next thing that this asks for is the transformations. The transformations are your A, H, and K values. So that's where those come from. So if I look at this example, my A value is 2. So that tells me there is a vertical stretch by 2. And then I have x minus 3, which tells me that this also went right 3 units. And then I have the 1 on the end, which tells me that I went up 1 unit. So those are my transformations. The line of symmetry is a line that cuts this graph into 2 equal pieces. Your line of symmetry is always an equation. X equals a number, and the number that it equals is the x coordinate of the vertex. So this is x equals 3. Your domain are your x values from left to right. My graph is going to the left forever. So my x values are going to get more and more negative the more I go to the left. And so that means that this is heading to negative infinity. Going to the right, well, my graph is going to the right forever. So my x values are going to get more and more positive the more I go to the right. So this is going to positive infinity. So my domain is from negative infinity to positive infinity, or you could say all real numbers. Our range are our y values from the bottom of our graph to the top of our graph. Well, the bottom of my graph is my vertex. Here my y value of my vertex is 1. And then my graph is going up forever, so that's going to infinity. So my range is from 1 to infinity. Or you could say y is greater than or equal to 1. What I would like you to do now is go ahead and pause this video and see how far you can get on number 11. So if you have just unpaused or never paused and you haven't done number 11 yet, go ahead and see what you can do on that one. Don't just wait for me to do it for you. See what you can do on your own. Alrighty. So the first question is, what is the vertex? Well, remember, your vertex is always going to be of the form HK. So I'm going to change the sign of H and I'm going to keep the sign of K. So my vertex is at -2, -3. After -2 is -1, and then 0. Before -2 is -3, and -4. From here, I'm just going to plug in using my calculator to get these other values. And when I do that, I get -5, -3.5. There we go. So now I'm going to plot these points. And now I can connect these points to create a parabola. From here, we want to know the transformations from the parent function. The transformations are your a, h, and k values. First thing I see is that my a value is negative. So that tells me that I have a reflection across the x-axis. My a value is also 1/2, which means there has been a vertical shrink by half. X plus 2 tells me that I have also gone left 2 units from the parent function. Oops. And then x, or this -3 here on the end, tells me that it has gone down 3 units. The line of symmetry is the line that goes straight through the vertex that cuts the parabola into 2 equal pieces. It is always x equals the x coordinate of your vertex. So here the axis of symmetry is x equals -2. Your domain are your x values from left to right. My graph is going to the left forever, so that's going to negative infinity. My graph is going to the right forever, so that's going to positive infinity. So my domain is from negative infinity to positive infinity, which is the same thing as all real numbers. Our range are our y values from the bottom of the graph to the top of our graph. My graph is going down forever, so that's going to negative infinity. The top of my graph is my vertex, and that is where y is -3. So my range is from negative infinity to -3. Or you could say y is less than or equal to -3. Our last example today is a word problem. And so it says a soccer ball is kicked into the air. Its height can be modeled by the function y equals -2 times x minus 5 squared plus 50, where y is the height in feet and x is in this time in seconds. Graph the equation and label the axes. So they just told us that x was the time in seconds and y is the height in feet. So I want to begin where time is 0 because I want to start at the beginning, and I'm just going to fill in this until I get to the end of the table. The equation that they gave us, y equals -2 x minus 5 squared plus 50, is in vertex form. And because it is in vertex form, I can figure out the vertex. The vertex is going to be of the form HK. So my vertex is going to be 550. Change the sign of H, keep the sign of K. So this right here is going to represent my vertex. And what I'm going to do is I'm just going to plug in these values of x into the equation and get the corresponding y values. And from here, I'm going to plot those points. Now when I connect these to make my parabola, one thing that's going to be different with this problem is that I am not going to have arrows at the end of my graph. And that is because I cannot have negative time, so I can't go back in time, and I can't have negative height. So the ball is not going to dig a hole into the earth and keep going, right? When the soccer ball hits the ground, that's where it's as far as low as it's going to get. So here is my parabola. Here's the height of the ball at time 0. And then the ball is kicked up into the air, it reaches its maximum height, and then it comes down and lands on the ground. So that is what this picture represents. Part B says, what is the ball's maximum height? The maximum height is going to be represented by the vertex. So my vertex, we said, was at 550 right here, right? There's my vertex and my line of symmetry. So the maximum height is 50 feet. After how many seconds does the ball reach its maximum height? Well, that happens after 5 seconds. Our next question says, when does the soccer ball hit the ground? Well, that's going to be when the height is 0. So if the soccer ball is kicked up in the air and then comes back down on the ground, Then it's back down on the ground right here. This is when the height is 0 and 10 seconds have passed.